In this video, I'm going to go through and solve all the different types of equations that you need to do at higher. So there's the basic ones that are National 5, like number 1. Number 2, you want equations with sine, cos, tan with either 2x, 3x, 4x, 5x. Then you want ones where you've got sine of x plus or minus another angle. And then the last two types are the double angle formula ones where you've got sine 2x with another trig function and cos 2x with another trig function. So those are the ones that you use your information sheet for, you replace and you factorise. So we'll go through each different type. Okay, first type, this is like the ones that you do in National 5. So the first thing you do is you do your acute angle. Now I know that minus root 3 over 2 is an exact value. So the exact value for that one is 30 degrees. Now it's negative, so if we think about our cast diagram, we're looking for cos to be negative. Cos is positive in there and in there, so it must be negative in quadrant 2 and quadrant 3. So we've got an answer in quadrant 2, we've got an answer in quadrant 3. To get into quadrant 2, we do 180 minus the acute angle, so it's 180 minus 30. That would give me an angle of 150 degrees. To get into quadrant 3 is 180 plus the acute angle, so 180 plus 30 would take me to 210 degrees. That's it solved. We finished off by saying x is equal to, gather up our answers, so it's 150 degrees, and the other one is 210 degrees. So that's your basic equation. Now you can have this type here, where cos squared x is equal to half. There's no other trig function in that, it's just cos. So if we want to find out what cos is, that's cos squared. We take the square root of both sides. So that means cos x is equal to the square root of this whole thing here. So whenever I take a square root, remember I've got a plus answer and a minus answer, so I'm writing it down like that. But just now I'm going to split that root sign to root 1 over root 2. Square root of 1 is equal to 1. Root 2, we're going to keep that as a third, and it's equal to that. Now, we've got a plus value and we've got a minus value for each of these, and we put a wee plus and minus in there. So what that means is, whenever you've got a squared term, when you take a square root, you're going to have cos x equal to 1 over root 2, the positive one. But you're also going to have cos x equal to negative 1 over root 2. Now, what happens here is you're going to get an answer in all 4 quadrants. So whenever you've got a squared trig function like that, you're going to get an answer in 4 quadrants. Now, we know that 1 over root 2, we're talking about cos, so the exact value for that one has got to be 45 degrees. So the acute angle is equal to 45 degrees. But I know I've got 2 places where cos is positive. That's quadrant 1 and quadrant 4. So we can write down our answer quadrant 1, quadrant 4, that's 2 positive ones. We've got 2 negative ones. Cos is negative in quadrant 2 and quadrant 3. So basically, we've got an answer in all 4 of the quadrants. So in quadrant 1, we know it's 45 degrees. In quadrant 4, it's going to be 360 take away 45, which is 315 degrees. In quadrant 2, it's going to be 180 take away 45 is 135 degrees. And in quadrant 3, it's 180 plus 45, which is 225 degrees. So gather all your answers together, put them in a big bracket. So 45 degrees, 135 degrees, 225, and 315. That's them all in order. Now, next type are ones where you've got sine, cos, or tan, and you have got a number of x. You've got 2x, 3x, 4x. Now, these are nothing to do with your information sheet because there's no other trig function near with that. There's no other sine or cos. So what we do is we just do our acute angle, ignoring the 2x just now. So acute angle is sine to the minus 1 of 0.455. That turns out, use your calculator, and that gives me an angle of 27.1 degrees. So we're doing the normal thing, just the same as we did before. We're going to look and see where cos is positive. Cos is positive in quadrant 1 and quadrant 2. So we're going to answer in quadrant 1 and answer in quadrant 2. In quadrant 1 it is the acute angle, which is 27.1 degrees. In quadrant 2 it's 180 minus 27.1. That turns out to be 152.9 degrees. Now that's just what you would do in National 5. This becomes the higher part now. So instead of that just being x in there, there's 2x, but all you have to do is say, okay, 2x is equal to 27.1 degrees, or 2x is equal to 152.9 degrees. So we were asked to solve for x. We don't want 2x, so we're going to half that, so divide both sides by 2. When I divide that by 2, I get 13.55. I'm going to make that 13.6 degrees. And when I divide that by 2, x is equal to, we divide that and round it, we've got 76.45, but I'm going to make it 76.5. Now, that's me, I've worked them out. But the last wee thing you've got to know for higher maths is, if you've got sine 2x, that means that there's two complete graphs in 360 degrees. So what happens is it looks something like that. There's two complete graphs. That takes me to 360 degrees. And that goes up to 1, down to -1 and 0. So really what we were solving there is, we were finding 0.455, so roughly halfway. And if we follow that along to find where the graph is, there's 1, 2, 3, 4 answers. Now we've only got 2. So what we have to do is, we have to say, right, okay, there's 2 complete cycles in 360, so we'll work out the period of the graph. So it repeats every 360 divided by 2, so it repeats every 180 degrees. So the last and final wee step is we have to add on 180 to both of those answers to find the next 2. So those 2 answers there will be that one there and that one there. Now I want to find what that one is and that one is. But we know that they repeat every 180. So that one pairs with that one and that one pairs with that one. So 13.6 add on 180, that would give me 193.6 degrees. And add on 180 to that one, and that means I have got 256.5 degrees. So important, 2 things you've got to do for this type. Number 1, you've got to start off with your 2x is equal to your 2 answers, and then you solve that with equation by dividing by 2. But the most important thing is, you've got to say, right, we need to find all the other angles, or all the other solutions that are there, and we do that by adding on the period. Now, normally you would keep adding on the period until you get to 360, but I know if I add on 180 to each of those answers, it's taking me well out of 360, so I can stop there, and that gives me my other 2 answers. So, in total, we'll get x is equal to 13.6 degrees, 76.5 degrees, 193.6 degrees, and 256.5 degrees, and that's my full set of answers. Right, I'm going to do one with a 3x in it as well, just so that you can see how to solve that type. Okay, I'm doing this one with an exact value as well. So we've got cos 3x is equal to minus root 3 over 2. So what we're going to do is we're going to do the acute angle, we ignore the negative sign, and we're doing shift cos of root 3 over 2. That's an exact value for angle is 30 degrees. Now, cos is negative, so we'll look at a cast diagram, and where is cos negative? It's positive in there and in there, so it must be quadrant 2, quadrant 3, similar to that one I did a minute ago. So quadrant 2, quadrant 3. So answer in quadrant 2 is going to be 180 minus 30, which is 150 degrees. Answer in quadrant 3 is 180 plus 30, which is 210 degrees. Now, normally we would be finished there, but we have to do the higher maths part of it. So the higher maths part is, it wasn't just x there, it was 3x. So we do 3x is equal to 150 degrees, or 3x is equal to 210 degrees. Now, I don't want 3x, I only want x, so I'm going to divide both sides by 3. So that gives me x is equal to 150 divided by 3 is going to be 50 degrees. And here, 210 divided by 3 gives me x equal to 70 degrees. Now, because it's 3x, The last and final stage is I've got to look at the period of that graph. So the period of that graph is going to be 360 divided by 3. So 360 divided by 3 gives me 120 degrees, which means I've got to keep adding on 120 to these answers to find all the other ones that we've missed. So add on 120 degrees. That gives me another answer for x is equal to 50 plus 120 is 170. 70 plus 120 gives me another answer of 190. Now, I can add on another 120. Keep doing that until we're out of 360 range. So add on 120 to these. So 170 plus another 120 takes me to 290 degrees. Add on another 120 onto that, gives me an answer of 310 degrees. So I've got 6 answers. I've got to write them all down. So x is equal to 50 degrees, put them in order, 70 degrees, next one is 170, next biggest one is 190, next biggest one is 290, and the last one is 310. So that's the ones where you've got a number of x's, 2x or 3x or 4x. What you do is you solve it the same as you solved your National 5 ones. You get your 2 answers in the quadrants, and then you write down whether it's 3x, 4x, anything that could be there, and do your simple equation. But the last and final thing is you've got to remember to add on the period and keep going until you're out of 360. So for this one, we're going to solve x between 0 and 360. Tan x plus 20 is equal to 6. So we've got tan, you could have sine, cos, and you've got this inside the bracket. It's only one x. So the period of this function is 360 degrees. So we don't need to worry about adding on when we get to final answers. Right, so what we do is we do acute angle is equal to tan to the minus 1 of 6. So that gives me, when I put that into my calculator, it gives me an answer of 80.5 degrees. Now, this tan is positive, it's 6. So we're going to look at a cast diagram. So from the cast diagram, where is tan positive? Tan is positive in quadrant 1 and also in quadrant 3. So in quadrant 1, we've got the acute angle, which is 80.5. In quadrant 3, we've got 180 plus the acute angle, which is going to give us 180 plus another 80.5, which is 260.5. Now, that would be my 2 answers, but it's not x that's there. We'll get x plus 20, but it's okay because it just makes a wee easy equation. So it means that x add on 20 degrees is equal to the first answer, which is 80.5 degrees, or else x plus 20 is equal to 260.5 degrees, and we do that simple equation. So I want to get rid of that 20, take it away from both sides. I've got to take it away from that, so it's got to be 60.5 degrees. Do the same here, take 20 away from both sides, so x is equal to 240.5 degrees. So that's both of my answers, that one there and that one there. So everything like National 5 up to this point here, and then instead of writing down x is equal to that and x equal to that, it's really x add on 20 is equal to both answers, and solve those simple equations. So my solutions are x is equal to 60.5 degrees and 240.5 degrees. Okay, we'll solve another one with a bracket. So we've got cos of this thing is equal to negative 0.8. We're going to find the acute angle, and remember we drop the negative sign. So we do cos to the minus 1 of 0.8. Now when I put that into my calculator, I get an acute angle of 36.9 something. So I'm going to round that to 40 degrees. So that's to the nearest degree. Right, where is cos negative? So we look at a cast diagram. Cos is negative in quadrant 2 and quadrant 3. So I've got an answer in quadrant 2, I've got an answer in quadrant 3, so still exactly the same as what we did in that 5. So in quadrant 2, it's 180 plus acute angle. In quadrant 2, it's 180 minus acute angle, so it's 140 degrees. In quadrant 3, it's 180 plus your acute angle, which is going to be 220 degrees. Now, we would be finished at that point, but we're not, because it's not x that's there. It's x, add on 60 degrees. So x plus 60 degrees is equal to 140. X plus 60 degrees is equal to 220, and we've got two wee simple equations to solve. I don't want that add 60 to be there, so I'm taking away 60 from both sides. So x will be equal to, if I take 60 away from that side, it's going to give an answer of 80 degrees. Over here, take 60 away from both sides, and I take 60 away from there, I've got 160 degrees. Okay, so two answers, x is equal to 80 degrees and 160 degrees. Now, just one thing I want to point out just now. If you end up with, say that was only 50 in there and we took 60 away and we get negative 10, if you get a negative answer for an angle, add on 360 and it'll give you the positive value. Okay, so just in case that comes up, if you get a negative angle, add on 360. If it's a single x, if it was two x's, then you would have to deal with it differently, but you wouldn't be given that one. But just remember, you need to add on 360. Okay, for this one here, we're going to solve for x in between 0 and 360, and we've got cos 2x plus 2 cos x minus 3 equals 0. There is a double angle with another trig function. That could be cos or sine in there. So we've got to replace that using our information sheet. Remember, we've got three formulas for cos 2x. Cos squared x minus sine squared x. 2 cos squared x minus 1, or 1 minus 2 sine squared x. We'll look to see what the middle term is. It's in terms of cos. So the presence of that cos x here tells us to replace cos 2x with the 1 that contains the cos. So 2 cos squared x minus 1. Okay, so if we're going to do that, then what we've got for this is, I'll fill it in here, I've got, instead of cos 2x, I'm going to put in 2 cos squared x minus 1. So that's replaced. I've now also got plus a 2 cos x degrees. I've also got a minus 3 in there, and it's all equal to 0. You always make these things equal to 0. So if there's another number over there, then deal with it so that becomes 0, either add or take away it. Right, we need to tidy this up because we've got a minus 1 and we've got a minus 3. So the 2 cos squared x's can't really do anything with that. The minus 1 and the minus 3 will make minus 4, but I've also got a plus 2 cos x degrees in there. Minus 1 and minus 3 makes minus 4 equal to 0. Now we're going to factorise, but right away I can see there's a 2 and a 4. So I'm going to take out a common factor of 2. And when I take out a common factor of 2, that gives me cos squared x plus cos x minus 2 is equal to 0. Now, divide both sides by 2. That disappears. Nothing divided by 2 is still nothing. So now what I've got is, I've got a quadratic equation that I want to solve. Now, if it makes things easier, just call that c squared plus c minus 2 equals 0. So we're looking for factors of 1 times negative 2 is negative 2. It's a prime number, so there only is one pair of factors, 1 and 2. But because it's negative, it means that one of the factors is positive and the other is negative. So we could either have that pair or that pair. Now we're looking for something that adds to plus 1 for the middle term. Minus 1 plus 2, that gives me plus 1, so that's my factors there. Those two would give me negative 1. We don't want negative 1, we want plus 1. So we're going to split this to c squared minus c plus 2c minus 2 equal to 0. Split it right down the middle. Highest common factor there is c. That'll give me c minus 1. I know this bracket's going to be c minus 1 as well, because it's got to be the same. What's the common factor I'm pulling out? Is a plus 2. Okay, I can form my two brackets, which would give me c plus 2, which really means cos x plus 2. And the other bracket would be cos minus 1, which means cos x minus 1, and it's all equal to 0. So we've got two brackets equal to 0. I'm going to take each one in turn. I'll write them over here. So I've got cos x plus 2 equals 0. The other one is cos x minus 1 equals 0. Now, if cos x plus 2 equals 0, that means that cos x is equal to negative 2. Okay, cos only goes up to plus 1 and down to minus 1. So there's no solution for that one. So no solution. We don't need to do anything else with that one. This one here, we need to rearrange this one. So add 1 onto both sides. That means cos x is equal to 1. Now, when you get a cos or a sine equal to 1, 0 or negative 1, we have got to draw the graph to get our solution, our answers. So cos graph looks like that. It goes up to 1, down to minus 1, that middle bit is 0. I want cos x equal to 1, so I find the 1, there it's there. I read across until I find two places where it meets the graph. It meets it at the end and it meets it at the start. So that means x is equal to either 0 degrees, read down to the angle, that's 0, and that would be the end of it is 360. And that's our two solutions. So x equals 0 degrees or 360 degrees. We'll now solve another type. So this is cos 2x, but this time it's sine that's with it. So the presence of that sine in there tells me I've got to use cos 2x equal to 1 minus 2 sine squared. So it's got to be the one with sine in it, because that's sine. So when I replace all of that, cos 2x becomes 1 minus 2 sine squared x. That's that bit. Then I've got plus 3 sine x degrees. And the minus 2 is equal to 0. So we really need to tidy this up. We've got two lots of numbers here. We've got a plus 1 and a minus 2. So we'll write down the minus 2 sine squared x, the plus 3 sine x, and we'll tidy up the number part of it. So we'll get plus 1 and minus 2. So that's going to give me minus 1 equal to 0. Now, we've got our quadratic. There's a squared term there. I do not like a negative squared term, so I'm going to take them all over the other side, which is equivalent to multiplying every term by negative 1. So that becomes 2 sine squared x. That will now become minus 3 sine x. And that will become plus 1 equal to 0. So now what we want to do is we want to factorise that. So if you want, you can write down 2s squared minus 3s's plus 1 equals 0. We're looking for factors of 2 times plus 1 is plus 2. 2 again, prime number, so it's only 1 and 2 are the factors. Because it's positive, it tells me that they're both the same sign, so it's either plus 1 and plus 2, or they both could be negative, so it could be negative 1 and negative 2. Because we've got negative in there, I know it's the negative ones. So 2s squared minus 1s minus 2s's plus 1 is equal to 0. So we're going to split that right down the middle. Okay, so I'm going to split it right down there. I'm going to take out the highest common factor, which is going to be s. So I've got s bracket 2s minus 1. And I know I've got to have 2s minus 1 here. Now, because that's negative 2s, I'm going to pull out negative 1. And just check that that's okay. So negative 1 times 2s is negative 2s, negative 1 times negative 1 is plus 1. Okay. So my two brackets are s minus 1, and the other one is 2s minus 1 is equal to 0. I'm going to write that back with sine in it. So I've got sine x minus 1 equals 0, or 2 sine x minus 1 equal to 0. Okay, tidy that up. We're going to add 1 onto both sides. So sine x is equal to 1. Here's this one again. If it's equal to 1, 0, negative 1, I need to use the graph. So sine graph, it starts at the origin, it goes up and round like that. I want sine x equal to 1. So 1 is up here. So we're going to read across from 1 till we get to the graph, and we get to that bit there, and that stands for 90 degrees. So x is equal to 90 degrees. No other solution for that one. Doesn't meet the graph anywhere else. This one here, we'll rearrange this one. So we'll add 1 onto both sides. We'll divide by 2. So that means that sine x is equal to half. Now, that there is an exact value. So if sine x is a half, the acute angle is going to be, and make sure you know your exact values, it's 30 degrees. Sine is positive. So we've got an answer in quadrant 1, we've got an answer in quadrant 2. Answer in quadrant 1 is the 30 degrees, the acute angle. Answer in quadrant 2 is 180 minus the 30, the acute angle is 150 degrees. So that one then gives me a set of solutions of 30 degrees, put them in order, 90 degrees, and 150 degrees. Now, don't worry, if you don't put them in the correct order, you'll still get your marks as long as all your working is correct up to that point. Okay, this is the last type. So we've got 2 sine 2x plus 3 cos x. We've got a double angle in there. So look at that information sheet. There is only one replacement for sine 2x, and it's 2 sine x's times cos x. But be careful, because in this example, there's a wee 2 in front of it. So there's that 2. And now I'm going to replace sine 2x, and sine 2x is 2 sine x cos x. Then I've got plus 3 cos x, and all of that is equal to 0. Right, now we need to multiply this out. So 2 times 2 is 4, so we've got 4 sine x cos x plus 3 cos x is equal to 0. Okay, when you've got the sine 2x one, that is always going to be a common factor. So we're looking to see what's the common factor between that term, and it's got to be cos. So I'm pulling out cos, which means I'm dividing all terms by cos. When I divide that by cos, that disappears. I'm left with 4 sine x, a plus sign, and I'm dividing that with cos x, so I'm left with 3, and that is equal to 0. So we've got 2 brackets equal to 0, so from that I can say cos x equals 0. But we've got 4 sine x plus 3 equals 0. Okay, cos x equal to 0, there's one of the special ones, equal to 0, 1 or minus 1. That means use the graph. So draw the cos graph down, it looks like that. I want the bit where it's 0, so 0 is right on the axis there. So we'll read across until we find the 2 places. There it's there, and there it's there. Those 2 angles are 90 degrees, and that one there is 270. Okay, now I've not put numbers onto those graphs. I assume that you know how to do them. Right, this one here, we've got an equation to solve, so we're going to take 3 away from both sides and divide by 4. So that means that sine x is equal to negative 3 over 4. So what we want to do is we want to get an acute angle. So we're going to do shift cos of 3 over 4. And when we do that, I get an answer of 48.6 degrees. So the acute angle for this side is 48.6. Okay. Now, cos is negative. So I know that where is cos negative? Cos is negative in quadrants. So quadrants negative is got to quadrants 3 and quadrant 4. So quadrant 3 and quadrant 4. So quadrant 3 is going to be 180 plus 48.6, and that gives me an answer of 228.6 degrees. And the other one is going to be 360, take away 48.6, and when I take that away, that gives me an answer of 311.4. Okay, so what we want to do then is we want to write all of those answers down. I'm running out of space here, so we'll write them over here. So x is equal to, the smallest one was 90. The next one is 228.6. The next one was 270, and the last one was 311.4 degrees. And that's that one solved. So that is one of each type of equations that you have to be able to solve for higher maths.